name, I am one of the adoptee, and Cloud4Sky community is a community of cloud computing enthusiasts. So we are here to learn, to network, and to uplift each other. That is the mission, vision of Cloud4Sky community. If you're here for the first time and you're hearing Cloud4Sky for the first time, or you heard it somewhere in the grapevine, or we are a community of cloud enthusiasts. And if you'd like to join us, we'll let you know in the chat how you can join us. My co-host, Patrick, will let you know in the chat. If you are a part of Cloud4Sky community, you know that this month we have a theme which is design from the SDLC lifecycle. And in this month, you should work on learning how to create system architectures, how to define data flows, how to select technologies, how to design user interfaces that are efficient and align with the requirements. So for that particular theme, we have a speaker tonight, James Juma. I will tell you something about James Juma. He is very seasoned. Yes, he's very seasoned. He's a cloud solutions architect, and he's based here in Nairobi, Kenya. And he works as a solutions architect for Rainforest Alliance. He's previously worked for Huawei, Silicon Overdrive, so he has extensive experience in designing, in implementation, in managing multi-clouds. He is also, I should mention, the co-founder of Resource Cloud Academy. Just Google Resource Cloud Academy or join them on LinkedIn. We'll share the link later. He leads a community of young cloud enthusiasts. He provides hands-on projects and labs in that community. He is a graduate of JQuat, and he has a very, very robust certification portfolio. Check him out on LinkedIn. Solutions architect, developer, associate, SysOps associate. I will go on and on and on and on. This is a seasoned guy. But above all, James is very passionate about cloud technology and even about community development. And he's someone who advocates for continuous learning. And that's why he's very actively involved with Cloud4Sky community, because he frequently shares his insights through webinars, hackathons, workshops, bootcamps. He is ever present. So I would like to welcome him. Juma, are you there? I saw you on the call.
Yes. Hi, Leah.
How are you?
Me? I'm good. How about you?
I'm very well. Nice to hear you.
Yeah, it's also a pleasure hearing from you.
Yes. I have stopped sharing. I would like you to introduce yourself, and then we can get on with the
Perfect. Thank you.
Yes.
Thank you again, Leah, for that great introduction. Hi, everyone. The weather is also chilled here in Kikuyu, but above all, kahawa iko karibu. So my name is James Juma Sindani. As Leah has mentioned, I currently work as a solutions architect at Rainforest Alliance. So this is an NGO that deals with helping farmers to do sustainable agriculture while protecting the environment. So making sure that things to do with deforestation is mitigated, making sure that we are protecting the indigenous trees and rainforest. And so what I do is I'm in the IT department, and I take care of systems and applications for end users who are farmers across the world. But apart from that, I also served as a cloud solutions architect in Huawei Technologies and previously Silicon Overdrive and Sparcheck. Yeah, and I'm a lover of technology, especially cloud, and that's why I'm here. So I'm going to share my presentation around around cloud. So just give me a few seconds as I go ahead and share my presentation. So I'm just going to share the entire window and let me know once you can see it. Yeah, so can you see my presentation?
Yes, we can.
Perfect, perfect. My topic is going to be cloud architecture design. So, scalable, secure, and sustainable architectures in the SDLC. Of course, the presenter is James Juma Sindani. And this is how I'm going to do the presentation. I don't know what you had covered previously, but just allow me to start with introduction to cloud architecture and SDLC. Then I'm going to have a look at the three pillars of of the topic of today, which is scalability, security, and sustainability. And yeah, that will be it. So over to introduction to cloud architecture and SDLC. Of course, probably majority of you are aware what cloud architecture is, but if you're not, actually cloud architectures, which refers to the components and structures required to implement cloud computing. So things it includes front-end platform, back-end platform, cloud-based delivery networks, servers, security, and so on. So think of it uh, 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 just as in construction. Of course, before you get your house, the first thing is that you have an idea. You as the house owner, you're going to have an idea of the type of house that you want. Is it a two-bedroom house, three-bedroom? Is it a flat roof? Is it a hidden roof? Is it modern architecture and all that? So that's the idea. But remember, you don't have the skills, the experts of coming up with this house. That's why you need to look for someone who can be able to relate your pain points or your idea in a design that later on other experts can take on and build the dream home or house that you want. So that's when you call an architect, generally an architect, who's going to design the house according to the specification that you're going to give him or her. So he's going to put in all the measurements, where the door is going to be, how the lighting is going to be, and all that. Then later on, the architect is going to hand over to the civil engineers or construction engineers who are going now to set up the building. So this is just in building and construction, but the same relates to any IT. That's why it's called infrastructure. You need to have an idea. You as the end user, you need to engage architects to map your ideas into a design. Then the architect is going to collaborate with the engineers in the implementation. So yeah, just think of it that way so that you cannot actually forget. So what are some of the key characteristics of cloud architectures? Of course, essential characteristics are on-demand self-service, because remember, you need to have an architecture. Remember, you're going to access this infrastructure remotely from your location, right? So there's on-demand self-service, and also the other part is the services that you're going to deploy. You're going to be charged according to the time you're using these resources. So if you just want to use it for 1 month or less, you're just going to be charged for that, that period. They're not going to be charged any charges to do with hardware installation and all that. So broad network access, of course, as I mentioned, you're going to, cloud is accessed remotely. So we need to have that network connection. Then you have resource pooling, rapid elasticity, and measured services. Therefore, it allows organization to scale resources quickly, right? And of course, right now the conversation is always around microservices, things to do with decoupled architectures, whereby if you have an application, you break it down into small components, which can then communicate with each other. And the reason why a lot of organizations are shifting towards microservices is one, cost efficiency, effectiveness. Two is maintenance. It's easy to maintain different components. So if there's one aspect of the component is down, the others are not affected. So you can enable cloud engineers to work on that specific component that is down without affecting the others. So of course, the cloud service model that you have, infrastructure as a service, platform as a service, and software as a service. So infrastructure as a service, these are just virtual machines. Platform as a service, there's a layer. It's a platform for development. So there's a layer that has been abbreviated and being handled by the hyperscalers or the cloud providers. Then for SaaS, software as a service, actually it delivers ready-to-use application over the internet. So each caters to different organizational needs. So that's just a general introduction of cloud architectures. And now introduction to SDLC, the definition and importance. So SDLC is a structured process for producing high quality software that meets customer requirements. It ensures a systematic approach to software development and maintenance. So common SDLC phases include planning, requirements, gathering, design, implementation, testing, deployment, and maintenance. So as you can see, we have a number of processes or phases that are involved in SDLC. And of course, each process you need to bear in mind. One is the objective that you have, but also best practices of handling these different phases. So understanding these phases is crucial for managing software projects efficiently. Then, what are some of the SDLC models that you have in Campus? I learned of Waterfall and Agile, and of course, we also have DevOps. So Waterfall is a linear sequential approach. Agile is iterative and flexible. So in Agile, it's like you start with MVP, and then you improve on that MVP with time. Then DevOps, of course, this is it integrates development and operation. So choose the model that best fits the project needs and organizational culture. So that's just an introduction of cloud architecture and SDLC. And next, we're going to have a look at the three pillars that I highlighted in my heading. That is scalability in cloud architecture, the first one. So what is scalability? I think at this point, that is something that we all know, if I'm not wrong. But if you don't, actually, scalability is a way in which you can, I don't want to use the term scale, a way in which you can increase or reduce resources on time. I'll give you a scenario. So right now, if you've not filed your taxes, actually it's high time you do that before the system, starts misbehaving. The reason why these systems misbehave is one, there's too much traffic being experienced in the system. So if the architecture has been built with scalability in mind, it should be able to, increase resources. And in resources, I mean virtual machines, if they're using virtual machines and database, so as to meet, the traffic, the increased traffic that is being experienced on this application. And of course, it needs to be automated because you won't have an SRE or a cloud engineer who is going to be there 24/7 to delete resources or spin up new resources according to traffic being experienced. Right now, technology has made work easier. Actually, scalability is an automated process. You just key in the metrics, the specification that you need, then it can be able to scale up, down according to the traffic that is being experienced in your application. So why does scalability matter? Matters actually. So scalability ensures that the architecture can handle increased workloads or user demand efficiently. Therefore, it's essential for maintaining performance and availability. So if a system is unable to scale, actually it's going to have poor performance, and most of the time, availability will also be compromised. You'll be in a situation whereby the site cannot be reached due to too much traffic being experienced at the same time. So it's like, I'll give you another typical example. It's like you have a door, uh, and you have like 10 people who want to pass through that door at the same time. So if the door is not expanded, actually no one is going to get through that door. So scalability is there to make sure that when users are many, the door is expanded. When users are few, it shrinks. So impact of poor scalability. um, Poor scalability can lead to performance bottleneck, system downtime, and the negative user experience. Hence, it's crucial to design with scalability in mind. And remember, as I am presenting, at the back of your mind, just try to see these um, where these are, if it's scalability, which stage in SDLC should we apply scalability? I believe it should be in all stages. I'm not a developer, but I believe that's something that should be considered. So what is the cost implication of scalability? Proper scalability can optimize resource usage and reduce cost during peak demand. Of course, over provisioning and under provisioning can both lead to unnecessary expenses. And that's why it's quite key to automate this process, but also bear in mind the cost implication. Because if you're going to spend resources, it means that you're going to pay more for the time that these resources are being utilized. So you need to be careful on scalability. Make sure that liaise with the organization that you're in to be able to find out the budget that is allocated for your cloud environment. That will be it will help you to see how you can achieve scalability. So design for scalability, of course, there are different scaling options. We have horizontal and vertical scaling. Actually, horizontal scaling, it involves adding more machines, while vertical scaling involves upgrading existing hardware. So let's say if it's a VM with 2 vCPU and you want to scale that VM, you can be able to increase the vCPUs to 4, or maybe the RAM to, if it's 8 to 16. Then horizontal scaling, it's adding more machines. So if it's 2 vCPUs and 16 GB of memory, and according to the traffic being experienced, this VM is not able to handle the traffic. There's another VM is actually created so that through load balancing, traffic can be distributed across these two VMs. So this is the example is on infrastructure as a service, but I believe the same applies to microservices. If you're using Kubernetes, I believe again scalability is going to be in handy, both horizontal and vertical scaling. Yes, then load balancing techniques. Of course, we have different. Many times, scalability will not actually be effective if you don't have load balancing techniques. Because think of it, we need a mechanism, we need a service that can be able to distribute the incoming traffic across the sources that have been scaled. Or especially on horizontal scaling, which involve adding more machines. So load balancing is going to distribute incoming traffic across multiple servers, preventing any single servers from becoming overloaded. Then, of course, we also have auto scaling strategies. Now, scalability consideration in SDLC. Yeah, as I mentioned that, of course, scalability is involved in various stages. So scalability in planning phase. Access expected growth and plan for scalable architectures early in the planning phase. It's more cost effective to build scalability from the ground up. Yeah, so I think this is self-explanatory. If you're building a system, you need to access the accepted growth and plan for scalability. You don't want to be in such a situation whereby you have, undermined the scalability in the planning phase, and you go all the way to the testing phase and realize that your system is failing because you didn't, put scalability in action. You didn't give enough resources. You didn't, have a great scalability strategy in the first phase. So planning phase, always make sure that you've actually planned for scalability. Design phase, the same thing, and testing phase. So use modular design and stateless component to facilitate scalability. Microservices architectures and containerization support horizontal scaling. Then for scalability in now the testing phase, you need to conduct load testing and stress testing to identify scalability bottlenecks so that you can be able to, fix any issues at that testing stage before going over to production. So performance testing should simulate real world traffic patterns. So that's scalability. The next one is security. Why is security important? One is, compliance. So you need to be, if you're creating an application for organizations, for customers, you need to be compliant with regulatory bodies such as GDPR, HIPAA, and I think we have Kenya Data Protection Act. So for handling sensitive data, or what you call PIIs, ensure that the architecture meets all relevant compliance requirements. Then potential security threats in cloud. Of course, the common threats that we know include data breaches, malware, distributed denial of service attacks, and inside threats. Therefore, a layered security approach is necessary in order to safeguard your application. So why does it matter? Security is vital for protecting data, maintaining customer trust, and complying with the regulations. A secure cloud architecture protects against threats. What are some of the security best practices that are there in while you're designing in cloud? The most common one is, of course, identity and access management. So IAM controls user access to resources, ensuring that only authorized individuals can access sensitive data, implement least privilege principles. Now, for data in transit or data, for data in transit or at rest, you need to have encryption in place. So it protects this data and prevents unauthorized access. Use strong encryption algorithm and manage keys securely. So for transit, of course, you need to have an SSL certificate so that you can be able to use SSL TLS to use port 443 for secure, internet access instead of port 80. But on top of that, you also need to add, other security services or features such as web application firewalls and VPN connections, so that you can be able to, safeguard your applications or the software that you're building. So on the third layer, the network security, which includes firewalls, VPNs. So firewalls and VPNs, they protect the network from external threats, isolating resources, and encrypting traffic. Yeah, so let's have a look at security consideration in SDLC. So security in requirement gathering, because this is a stage that is involved in SDLC. You need to identify security requirements early and incorporate them into the project plan. So consider threat modeling to identify potential vulnerabilities. So what it basically means, you need to have a proactive you need to incorporate these security requirements earlier in your SDLC stages, and consider threat modeling to identify any potential vulnerabilities. Then in implementation stage, which is quite crucial, especially on security, we need to use secure coding practices and conduct regular security audits. So implement static and dynamic analysis tools to detect any vulnerabilities. Then in the testing stage or phase, I think this is when our penetration testing and vulnerability assessment comes in handy to identify any security flaws. So security testing should be integrated into the pipelines, CI/CD pipelines. Yes, and finally, sustainability in cloud architecture. So why sustainability is important? Uh, Sustainability, of course, we're referring to protecting our environment. So sustainability reduces environmental impact, lowers energy costs, and improves corporate social responsibilities. We need to advocate for green cloud architectures to minimize resource consumption. So environmental impact of cloud computing. Remember, in as much as we are, having remote access to these servers, they are sitting in a data center, and this means they're consuming, they're using electricity to power them up. They are consuming a lot of energy and what is the word? And emitting carbon into the environment. So as you design for these softwares, you need to bear in mind sustainability. You need to bear in mind sustainability. You need to minimize on resource consumption. If your application is going to consume less resources, just do that. Stop over provisioning, because in as much as it's going to have a cost implication, it is also going to affect our environment through carbon emission. So I think this is something that we overlook because, again, we know that we think that it does not have an impact, but for the long term, it definitely got an impact on our environment. And we also advocate for using renewable sources of energy such as solar cells and panels. So cost benefits of sustainable practices. These practices can reduce energy consumption and lower operational cost. So they optimize resources, use it to minimize expenses. As I mentioned, you just need to create an environment that is ideal for your application. You don't need to overdo or in that case to underdo, also to underquote or overquote. Just make sure that you are designing to meet your application needs. So what are some of the strategies for sustainable cloud architectures? One is energy efficient resource utilization, optimize resource allocation and use autoscaling to match demand, avoid over provisioning and shutting, and also you need to shut down any idle resources. Then now the physical part, data center efficiency. We need to utilize data centers that use renewable energy, efficient cooling systems. Location of data centers impact its overall environment footprint. And finally, virtualization and containerization. So they reduce resource consumption by maximizing hardware utilization, consolidate workloads to improve efficiency. So the third point is actually advising us against using bare metal servers. Instead, use virtual machines. And if not, you can actually go ahead and also do containerization, because virtual machines, containers are lightweight as compared to virtual machines and bare metal servers. Then finally, let's now have a look at sustainability consideration in software development lifecycle. One, sustainability in the design phase. So select energy efficient technologies and design for optimal resource utilization. Design with sustainability in mind from the outset. Then in the deployment stage, deploy application to regions with cleaner energy sources. So you need to find out these regions that are using, renewable sources of energy. And if you are indeed the love of environment, you need to be able to spin up your resources in this region that are using cleaner energy sources. So location impacts the overall environment footprint. Then finally, monitoring and optimization. Monitor energy consumption and optimize resource usage continuously. Track KPIs related to energy efficiency. Yes, and that brings me to the end of my presentation. Thank you so much for listening. And I think at this point, I will welcome any questions from the audience. I'll just stop sharing. Where are we? Here we are. Stop.
Thank you, Juma. Is there anyone who has a question?
Yeah, I think Dominic Morara has a question. Domi?
Hello.
Yes, hi Dominic. I know you never lack questions, so yeah, go ahead.
Man,
Or you
I
can
just
just
joined.
say
I
hi.
just maybe I can say I just joined like right now, a few minutes ago, like 2 minutes ago. Uh, maybe I can say hi to everyone. I hope you
Yes,
guys are
yes.
good.
Yeah, that's okay.
Yeah. Thank you.
You're welcome, Dominic. Anybody with a question? It seems they did well understand. Yes, I know I did. And if you'd like to connect with James Juma, the link is on the chat. You can connect to him on LinkedIn. And if you would like to join Cloud4Sky community, please do join us. We do have a challenge this month for design in the SDLC. So if there is no question, anybody with a question, you may raise your hand or ask in the chat. I don't want to leave anyone out. Thank you, Alex. Alex says it was a nice session. Yes, Dominic, you missed a lot. Okay. So thank you, James. Thank you very much. I hope we have takeaways from this session. If there are no questions, I am going to end it here and wish you a lovely evening. So this is goodbye. Thank you so much for coming in. Look out for our next webinar.